Welcome back. So in this video, we're going to start getting ourselves into the great habit of writing constructors for all of our classes so that every time a instance pops out of the mold, we also make sure that we set it off in the right direction. So this is a bit like powering up computers when they come off the factory line and setting their state, loading software onto them, right? So the mold makes computers, the class pops out computer instances, but what the constructor does is basically loads the software into the computer as it leaves the factory so that you get all that annoying Dell default software and stuff. So that's what we're doing here, but in a good way. By the end of it, what we'll have is when we instantiate the new game, we'll actually know what its state is because we'll know that this is being reset automatically, and we'll actually be calling the BC game reset function and knowing that we have complete control over when the game state is set back to try one and maximum tries. So all good stuff. Let's dive in and see how it works. So let's dive right in and see what a constructor is. The way that you create a constructor is to just take the name of the class and make a method with that name. So what I've put there at the top of the header file is the constructor. Now there is actually something called a destructor, which we won't bother with now, but it's the same thing with a twiddle in front. Okay, so that is a constructor. When you first create the object, instantiate the object here, we make this thing called BC game, comes out of the mold, right? This is the mold, and this instance pops out the mold. Then it's going to look for a constructor. And if there's any code in the constructor, it's going to run it. So we've declared a constructor. Let's go ahead now and define that constructor. There it is. Here's the constructor. So let's imagine, for example, that reset one of these guys. Let's see which one of these takes precedent and see what happens. So we've got my current try and my max tries is 5 and 1 respectively. Let's, in the constructor, try setting these values to silly values. Okay, both 666 or something. So let's see if this works. Now we can't do a cout right here at the class level. We'd get this error, illegal for class. But we are allowed immediately inside our main method to go something like standard cout BC game dot get current try, for example. Let's see what comes out. 666. So the constructor value has been used. Why? Well, because we have instantiated a new game object here, and initially these values would have been used, but then they got overridden by the constructor at runtime. So these values are the compile time values, and these are the runtime values, okay? So we don't want both. It's kind of confusing. It's not clear what's where. So if we're going to use a constructor to set these values, we don't want to be setting them here. So let's take away the initializations here. And if you want to, you can signpost yourself. C constructor for initialization. Okay, so you construct here if on each subsequent play of the game, you didn't need to change these things, but we do. Every time we go around the main game loop and play game, we're going to need to reset the game somehow. So let's change these to my current try is 1 and max tries is, say, 5 for now. Okay, let's just run and see how this works. Try 1, enter your guess. Okay, so this is running, and when we first construct a new game, it has got values that are set here at runtime in the constructor. That's cool. Are you clear on what's going on there? When the thing pops out the mold, the constructor's called automatically. It's like a factory leaving check, and these things are set. That's fine. But we're also going to want a reset method, aren't we? If we look here in play game, then we're going to want the first thing we do in play game actually is to reset the game state. Because remember, we play the game multiple times. We print an intro, play a game, play again. Okay? So we're going to want to go BC game dot reset at this point. So if we're going to have a reset method, that's going to do exactly the same as the constructor, isn't it? The reset method is just going to set these things and possibly some new things for now. So I've got a simple challenge for you. I want you to write the reset method and call it from the constructor. It's just going to do this. It's literally, we've got a cut and paste operation for you pretty much. So I want you to write and test reset. Initialize all the member variables, set the max tries to 8 instead of 5, use the appropriate constant for the magic number, i.e. the number 8. Remember how we did that earlier? We said we don't ever assign numbers above 2 unless they're going to a constant. and check that it works by using cout as you need to convince yourself that the reset method is working. And as a bonus, call reset from the constructor. But if you don't know what that means, then just don't do it, and you'll see my solution in a second. Okay, see you in a sec. Welcome back. So literally, I'm going to take these guys here, pop them into reset, my current try and my max tries. I am going to set max tries to 8, and then I'm going to call reset from the constructor. That's fine. You're delegating the job effectively down to this reset, which is really neat now because we don't have any initialization here. We don't even have any initialization in the constructor. The constructor is so simple that if we want to, we can write things all on one line like this. So what does reset do? Well, you can right-click on it, go to definition, and we can go and see what reset does. Cool. That answers that question. What are the initial values? So this says see the constructor for initialization. We have a look at the constructor, and it just reuses reset. So actually, all eyes point to reset as being the only thing in our entire code that resets the game. And it's a very natural and clear place to look. So we're being good, we're doing a constructor, but we're reusing this code, a place for everything and everything in its place. There is only one place in your entire code that these things exist. Now, there is one thing I want to do, which is just move some lines around a little bit, space a couple of things out, and get rid of my nasty magic number. Const expression, remember, because this is known at compile time. Max tries equals 8. And this is just getting in a very good habit to say to ourselves, if we're going to use magic numbers, then right now this is basically a waste of time. But what's likely to happen with your code is you end up with a bigger and bigger gap between where you define that constant and where you lose it later. And if that happens, then it means in future, if you want to access max tries, it's available across your entire program there. You can see its value, and you know that if you ever need to change max tries, you only need to search for it and find it once in your entire program. That's the whole point about these magic numbers, right? So I group those two together because they kind of logically go together. I could go to find and replace, quick find, max tries, and however big my code is, I would be able to quite quickly find the definition of max tries and change it just there. Cool. Congratulations. Hopefully you get the most important part of this video, which is that you declare a constructor like this, and then you define a constructor to do what you like, and that it's okay to call one of your own methods, especially something like a reset method, and then that means that when the object is constructed, the values are known, and when you run reset, you get the same values in this case. Cool. See you soon.